Alright, here we have lecture 2.2. So this is unit 2, lecture 2, and here we introduce and cover the concept of index numbers. So an index number provides a simple way to compare measurements made at different times or places. And an index number is essentially a percentage, is essentially what it is. It's this value divided by some reference value multiplied by 100. Basically, it's kind of like a percentage without the percent sign. Let me demonstrate what I'm speaking about. So if we look at this table here, we see average rent for a 2-bedroom apartment in 4 different cities. Now, this data is a little bit old. I think I pulled this up about a year ago, but I imagine it's largely the same. Probably hasn't changed too much. But if we look at this data, we see average rent for a 2-bedroom apartment in Savannah is $11.53 per month. In Denver, it's $16.49. San Francisco is $3,772. And in Springfield, Missouri, where I hail from, it's a whopping $669 on average to rent a 2-bedroom apartment. So what we're going to do is we're going to go ahead and write this rent, or represent that rent value as a percentage of the rent in Savannah. So of course, for Savannah that'd be 100%, but let's look at California. So that'd be $16.49 out of $11.53. So that's just, Denver's rent out of Savannah's rent. And if we write that as a percentage, and type that into our calculator, $16.49 divided by $11.53, that's 143.02%. So in other words, in Denver, Colorado, you are paying 143% of what you would be paying in Savannah. Right. If you were paying 100% of what you're paying in Savannah, that means rent would be the same, but you're paying 43% more in Denver than you are in Savannah on average. Now here's the scary one, San Francisco. It's no secret that San Francisco is notorious for having the highest rent in the nation. It even beats New York City. So let's go ahead and represent that average rent value as a percentage of what you'd pay in Savannah. And you get a whopping 327.15%. So in other words, in San Francisco, you're paying 327% of what you would be paying in Savannah on average. And guys, don't just copy these numbers down. I recommend you press the pause button, practice with your own calculator. Note that when I'm writing this as a percentage, I do have to move the decimal 2 places. So make sure you press the pause button, type that into your calculator, and verify and see what I'm doing to get these figures. Now, Springfield is the only one on this table that is cheaper than Savannah. So if we type that in, 669 divided by 1153, we get approximately 58.02%. So that means on average in Springfield they're paying 58% of what you'd be paying in Savannah. So roughly 40% cheaper than what you're paying in Savannah. Now here's the index numbers. The index number for Savannah would be 100. For Denver would be 143.02. For San Francisco, it would be 327.15. For Springfield, it would be 58.02. So like I was saying at the beginning of the lecture, the index numbers are essentially a percentage. It's kind of like writing a percent without the percent sign. Now, if you look at the heading, it says Savannah equals 100. What that's telling the reader is that Savannah is the reference value. So what we're doing here is, with this particular rent index or price index, we are representing all prices and all average rent values as some percentage of what you'd be paying in Savannah. In other words, we're just treating Savannah as our reference value. So that's why you can see for Savannah the index is 100, because you're paying 100% of what you'd be paying in Savannah. Right, if it's anything above 100, that means you're paying more than what you would be paying in Savannah. Anything below 100 means you're paying less. So let's go ahead and look at this example down here. Suppose you're paying 100% per month for your apartment in Savannah. How much would a similar apartment cost in San Francisco? So we're doing a conversion. So it's $1,000 for what you're paying in Savannah, And the way you want to treat this is almost kind of like a quasi-conversion factor, and that you're going to put the Savannah index in the bottom and the San Francisco index on top. So if you kind of want to convert for geography, so to speak, then wherever you're converting from, that index will go in the denominator, kind of like if you were canceling units. So that 1,000 comes from Savannah, so that means the Savannah index is in the denominator, which that index is 100, and then San Francisco index, if we look at our chart, is 327.15. And that will give us our answer. So that tells us that it's going to be 1,000 times 3,271.50. So an apartment that costs you $1,000 a month in Savannah, a similar apartment with similar amenities and similar quality level would cost more than $3,000 per month in San Francisco. So these indices are used in real estate quite frequently, and it allows you to do just a quick little computation for converting. And here we're doing it for entire cities, but if you actually get into the nitty gritty of this, different neighborhoods will actually have different index values. I'm sure you guys are all aware of that. Some neighborhoods are actually more expensive to live in than others. So let's look at this example. So suppose a studio apartment costs $1,300 a month in Denver. How much would a similar studio apartment cost in Springfield? So that $1,300 is a value from Denver. So since it's from Denver, then our Denver index will be in the denominator. So whatever that number comes from is the index that goes to the denominator. Now we are converting that to Springfield, Missouri. So that's what our index in the numerator will be. So Springfield index will go in the numerator. So we can go ahead and look at our chart. The Denver index, let me flip back over. The Denver index was 143.02. Whereas the Springfield index was 58.02. That's coming from that chart on the previous page. And now we can just type that into our calculator and see what we get. And divide by 143.02. And we get 527.38. So that tells us that a studio apartment in Denver that costs $1,300 a month, a similar studio apartment in Springfield will be about $527 a month. And actually, this is pretty accurate, guys. I lived in Springfield for many years. I shared a house with some roommates, but I had a few friends living in studio apartments in downtown Springfield, and they were paying either somewhere between $500 to $600 a month. So yeah, this is exactly in line. So we can use these index numbers to convert for location, essentially. Allows us to do a conversion for different locations or time periods. So speaking of converting for time, that's where we get to the Consumer Price Index, which is arguably one of the most important indices in existence, at least from an economics perspective. The Consumer Price Index measures changes in the price level of a market basket of consumer goods and services. So in other words, the Consumer Price Index tracks the purchasing power of the dollar across time. Naturally, $100 today cannot buy you the same amount of groceries as $100, say, 20 years ago. The purchasing power of the dollar has changed across time. So we can use the index numbers in the CPI, which stands for Consumer Price Index, to adjust for inflation. So at this point in time, you need to pull out that Consumer Price Index table that was posted on Folio. It was posted just above this lecture, you do need to reference that in order to understand how we're getting through these problems. So if you need to press the pause button, do so. Pull out that chart. Either I recommend printing it off or at least pulling it up in a different tab. We're going to be referencing that chart completely. So let's go ahead and look at this example here. Suppose you made $50,000 annually in 2015. How much would you need to maintain the same standard of living in 1980? So we got $50,000, and it's just going to be the same conversion like we were doing in the real estate problems. That $50,000, you got to ask yourself, what year does that come from? That comes from 2015. So that means that's the index number that goes to the denominator. And we want to ask ourselves, okay, what do we want to convert that to? We want to convert it to 1980. So that would be the 1980 CPI. So this is where you need to look at that chart. If you need to press the pause button, do so. If you look at that chart, the index for 1980 is 82.4. The index number for 2015 is 237. Those are coming from the chart. Again, press the pause button, reference that chart if you need to, and let's punch that into our calculator. And you get $17,383.97. So in other words, a $50,000 salary in 2015 is similar or is the same standard of living as a $17,000 salary in 1980. So this really, tracks the purchasing power of the dollar. So if you're talking to one of your older friends or your parents, and you're telling them that you're starting off at $50,000, and they want you to say, "Oh, that's a huge salary." Maybe you graduate, and your first job after graduation, you start out around $50,000. You're like, "Oh, wow, that's a lot of money." Well, you talk to your parents and say, "Well, what did you guys start off with?" And you say, "Well, we were only making about $15,000 a year when we first started our first career." Well, when you adjust for inflation, it's actually pretty close together. I'm kind of rambling here, but hopefully you can understand the significance of these numbers. Essentially is saying that a $50,000 salary in 2015 is pretty similar to a $17,000 salary in 1980. So yes, people were being paid far less in 1980 than they are today, but you got to keep in mind the dollar had much more purchasing power back then. In other words, $17,000 in 1980 was worth a lot more than $17,000 is today. All right. Let's go ahead and look at this. The average cost of a movie ticket in 1977 was $2.23, adjust for inflation. So you might look at that and go, $2 for a movie ticket? That's dirt cheap. Well, you got to take into context the time period. $2 in 1977 is not the same thing as $2 in 2020, right? Yes, that is less money, but you got to keep in mind, back in 1977, everybody was paid less. So we got to adjust this for inflation. So that $2.23 comes from 1977, so that means the 1977 index is going into the denominator, and we want to convert that to the most recent index we have. And if you look on the chart, we have the 2020 index. Now, they actually release these index numbers every month. So this is from the Bureau of Labor. So this is the federal government tracking the economy, and they release these numbers every month. So this is the number, I think, for August. Anyways, it's the most up-to-date number they've released. So if we look at our chart, the index value for 2020 is 259.9. And the index number for 77 is 60.6. So let's go ahead and adjust this for inflation. And we get $9.56. So now we got to ask ourselves, were movie tickets more affordable in 1977? Well, what's the average cost of a movie ticket today? Like, movie tickets today are on average around $10. It's been a few months since I went to a movie theater. Well, heck, with coronavirus, it's been longer than that. But I mean, I think the last time I went to a movie theater, it was around $10 or $11. So I would say, movie tickets today are about as affordable as they were in 1977. So there's not a big difference, actually. When you adjust for inflation and take into account purchasing power of the dollar through time, movie tickets in 1977 cost about as much then as they do today when you adjust for inflation. So you'll notice a lot of goods and services are pretty in line with inflation. So if the numbers are pretty close together when you adjust for inflation, that means it's a comparable amount. Now, some things outpace inflation, other things fall behind. For example, if you look at computers, if you look at the average cost of a computer in, say, 1995 and look at the average cost of a computer today, when you adjust for inflation, you'll realize that computers are way more affordable today. I know, it's very easy to become cynical in today's society, especially in the year 2020. It's super easy to be cynical, but there are bright sides. There are a lot of things that are way more affordable than they used to be. Generally speaking, computers are way more affordable than they used to be. It used to be in the 90s, if you wanted to own your own computer, you better have deep pockets because that crap was expensive back then. Today, it's pretty affordable to own a computer. And you can look at it, almost everybody does. Let's look at some salaries, though. So I think it's kind of fun to track salaries for time. So let's look at MLB salary. So in 1987, the average salary for an MLB player was $412,000. That's in 1987. Today, or at least in 2017, the average salary was a little over $4 million, or almost $4.1 million. Have baseball salaries kept up with inflation? Explain. In other words, are baseball players in 2017 making more than baseball players did in 1987 when you adjust for inflation? So what we're going to do is take that 1987 salary and adjust it for inflation. So let's go ahead and adjust that for inflation. So that's $412,000. So in the denominator is going to be the index number for 1987 because that's where that figure comes from, that $412,000. So if we look at our index numbers, the index for 87 was 113.6, and we're converting that to 2017, where the index is 245.1. And let's see what we get here. And you get approximately $888,919. So even when you adjust for inflation, those late 80s ball players were getting paid less than $1 million on average. Today they're getting paid well over $4 million on average. So you can see here that MLB salaries have greatly outpaced inflation. In other words, professional baseball players are making way, way, way more money today than they used to, even when you adjust for inflation. Even when you account for inflation, they're getting much, much larger salaries than they used to. If we're comparing apples to apples here, the ball players in 87 were making a good salary. They were making, almost $1 million a year when you adjust for inflation. But nowadays, it's well over $4 million. So the last topic for today is the rate of inflation. The rate of inflation is simply the relative change in the CPI. So we talked about how to compute relative change, and in the last lecture, So if we look at the index numbers from 2007 and 2008, let's go ahead and reference those real quick. So looking at those, we can see the index went from 207.3 to 215.3. So it's gone up, so our numbers should be positive. So we'll be doing 215.3 minus 207.3. It's been an increase. We want to make sure our numbers stay positive. So that's our order of subtraction. We get the order of subtraction correct so that we know what to divide by. When computing the relative change, you always divide by the value you subtracted. And we'll go ahead and write that as a percentage. And you get approximately 3.86%. So the inflation rate going from 2007 to 2008 was 3.86%. And you don't have to be a historian to realize that that time period, 07 to 08, is when we were talking about the recession, which was closely tied to this inflation rate that you see here. All right, on that note, we are done with the unit. You are ready to tackle the next homework assignment, so feel free to get started on that and have a wonderful day.